Our project consists of analyzing half a parabolic shot coming out from a PVC tube. And our group is composed by me, Charby Ortega, my friend Julio Oscar Martinez, and the guy who's really good with the drill, Andres Aguayo. The purpose of our research is to understand how parabolic shot works depending on its initial speed, and how that initial speed depends itself from the height of in this case, the water in a PVC tube. The materials we used were a PVC tube, a drill to make a little hole on it, and a bunch of silicone to try to seal the PVC tube, but as we will explain later, it didn't work. The math and procedure that we used was the following. First, we started by analyzing the volume of the cylinder, which is given by this formula: pi, radius, square, and height. In this case, height is water height, so we don't have to exactly take the PVC height. To know the velocity the water is coming out of the little hole we are going to drill in our PVC tube, we are going to use the following formula, which is 2 times the gravity per height. Also, in this case, height is given by water. So we have the same height affecting both formulas. To know how much water we are actually losing, we have to use the following formula. Volume loss is equal to the area the area of the cylinder, in this case this, pi square radius, times the velocity, which is, as we saw, 2 times the gravity per height. And again, height is water height, so we have water height in our free variables, in our free formula, sorry. So what do we do with this information? Well, we have our initial volume, and we know how much we are losing per second. Remember, this formula is meters squares per second, so we know how much water we are actually losing every second. What we did was to design a C program in which the user gives the radius of the cylinder, gives the height of the water, gravity is a constant, pi is a constant, and what we did was that we just took the initial volume minus the loss of it, and now we have a new volume. What happened? That with this new volume, we have a new water height, so we had to calculate this too. How did we do that? Easy. We took this new volume and we took h out of the equation. So if we take new volume is equal to pi per radius square per h. We already know pi and we know radius square, so we just have to pass these two terms down here, and we get new volume divided by pi radius square, and we got the new height. This made a loop, like we had to calculate this every time, and notice that as the height was decreasing constantly, so was the velocity. Because the velocity was decreasing constantly, so was the volume loss. So it wasn't exactly constant. Now we have to calculate the half parabolic shot. That's really easy. We take the velocity of the water coming out, multiply it by the time it takes the water to fall, and we have the distance. This time is given by the height of where the PVC tube is on, and we use the following equation. This equation allows us to have the time, and it will be equal to this. And this will be constant. This time doesn't change at any moment. So having all this information, we can make graphics of the half parabolic shot. Those graphics we'll be seeing right now. This was our actual data, what we obtained from the PVC experiment, which are not completely reliable because the PVC couldn't be sealed, so the water loss was more than the calculated. This is the graphic, as you can see. This is the practical graphic. These are our analytic data taking into account the water loss from the escapes, and it's kind of similar, as you can see. These two are kind of similar, but the utopic one, that was the one that we obtained from our C program, it's almost linear, like it's a linear loss of distance. So these were basically our results, and we concluded that the height of the water directly influences all the other parameters, and that for future experiments we hope we can have better practical results through having a better preparation of the materials. Thank you.
Thank you.
Creo que sí va a dar, sí va a dar. Y ya.
Solo que también te iba a ver.
¿Pero para qué?
No, pues la voz que sí.
No, todavía. Faltan. ¿Sabe también? Que los chorritos salen como muy dispersos. O sea, hay algunos que llegan
Sí. Ah, coño.
¿Qué pasó?
Coño,
¿Qué?
me cagó un maldito pájaro.
Ok, sí le voy a tener que quitar el volumen.
Mierda, coño. Mierda.
Ahí le pongo el app. Y aquí viene ese otro lado.
Cuando en las rayas rojas.
Porque vamos a darlo rápido porque ya me están asustando. Porque me están dando como.
Aquí frente a la Treviño. Arbolitos y vaquitas. Eso es tuyo.
Física.
No me lava la camisa.
Ahí le pongo el app.
Todavía un poquito. Hay un lap.
Y el último ya stop.
No, en el último dale el lap y ya el stop se lo damos.
Donde cabe el agua.
Se supone que sí. ¿Eh?
¿Qué tema de física es este?
Ahí está tiro parabólico, en verdad, casi.
Ah, ya.
Pero hay que, o sea, tuvimos que usar mucho volumen.
Ahí el app.
Ajá.